Good morning, scholars. Obviously, you can see I'm not here, so I'm audio recording the lesson for the first part of section 13.4, which is evaluating an inverse trig function. So we use inverse trig functions to help us when we need to find a missing angle, either inside of a triangle, which we'll do today, or for solving a trig equation, which we will do on Monday. So at this particular point, we worked with the basic trig functions. So the basic trig functions are sine, cosine, tangent, cosecant, secant, cotangent. So we use the basic trig functions when we are either right or if we're finding a side. So if we're writing ratios or finding sides, that's when we use the basic trig function. The inverse trig functions only serve one purpose, and that's to help you find angles. Inverse trig functions are for finding angles. And to find angles, the inverses would be sine inverse. It looks like sine to the negative 1 power, but that's sine inverse. Sine inverse, cosine inverse, and tangent inverse. So before we do anything with a right triangle or solving an equation, we're first going to look at how we do this inside of a calculator. So the very first part of your notes packet, which begins on page 21, is using the calculator to work this out. So to evaluate an inverse trig function using the calculator, the main thing here is that you round correctly. Most of the time, you're going to be rounding to the nearest whole number. Most of the time, we're rounding to the nearest whole number. Very rarely do we round to the nearest tenth, which is simply one number after the decimal place. So we'll practice doing it each way, but just know that most of the time, you're going to round to the nearest whole number. So using your graphing calculator, look at 1a. So 1a, this is sine, this should be to the negative 1, sine inverse 0.481. So you're looking for what angle will give you that value for sine. So in your calculator, this is how that would work. So in the graphing calculator, go to mode, make sure that the degree is highlighted. Remember, keep the calculator in degree mode. So to do inverse, you hit second, and then you hit the trig function that you want. Since it was sine, you're going to press sine. Notice that it brings up sine negative 1. So that's the symbol for inverse. Then you type in the number that you want, 0.481. Closing the parentheses is not a huge deal. Remember, close the parentheses if you're going to put something behind it. So it's not a huge deal if you don't close the parentheses here. And hit enter. So notice you get 28.7507338. Your notepad says round to the nearest whole number. So nearest whole number means you don't want any decimal places. There's a 7 behind it. So instead of 28, this is going to become 29. So for your answer, that's 29 degrees. And that's it. That's how you use the calculator to do inverses. So let's do another one rounding to the nearest tenth. That's cosine inverse 0.592. So again, we go to our calculator. We're going to hit second cosine. And we have 0.592. Again, you don't necessarily have to close the parentheses. If you do, it's fine. Hit enter. So this gives you 53.70093691. You're rounding to the nearest tenth. That's one decimal place. So one number after the decimal place, there's a 0. So that 0 doesn't change anything. So your answer in this case would be 53.7 degrees. And that takes care of 1B. So that's how you would go about using the calculator to evaluate an inverse trig function. For those people who are working ahead and filling everything in, 1C, you should have 68 degrees. 1D, you should have 87 degrees. For 1E, sine inverse of 0.894 is 63.4 degrees. Remember, it said round to the nearest tenth. And tangent inverse 1.137 is 48.7 degrees. So 1C through 1F, those are definitely ones to try yourself. And those are the answers that you should get. I'll pause for 1 second just to give you a moment to get caught up. Now we'll continue. So the first area in which you're going to find missing angles is inside of a right triangle. So we're kind of going back to right triangle trig here. If you're given a right triangle in which 2 of the angles are missing, this is how you would go about finding a missing angle. First, label your triangle. Hypotenuse, opposite, adjacent, based off of the angle that you need to find. So this is important. If whatever angle you're being asked to find, you're either going to see theta, or you'll be given the name of the angle they want you to find. So you're either looking for theta, or you're looking for the name of the angle that they want you to find. So in the case of example 2, angle A has the theta next to it, so that's what you're going to use to label. So across from theta is your opposite. Across from the right angle is still your hypotenuse, which means the 12 represents your adjacent. So that's your first step, label the triangle. Second step, identify the trig function based off of the information you have. Only one trig function can be used. So you have the adjacent and you have a hypotenuse. So this is SOHCAHTOA. So we're using SOHCAHTOA rules. Adjacent and hypotenuse lines up with the cosine function. So that's cosine theta, because we don't know what the angle is, equal to 12 over 13. So that actually takes us through step 3, which is setting up the equation. Step 4 is to solve it by using the inverse operation. So you need to set up the inverse operation and then use the calculator to solve it. That constitutes you showing your work. So set it up, this is how you would do. Equals the trig function, and you write it as the inverse. Cosine inverse 12 over 13. And then from there, you let the calculator do its work. Cosine inverse 12 over 13. So theta equals 22.6 degrees. So that's your answer if they wanted it rounded to the nearest tenth, which is 1 decimal place. If they wanted it at their whole number, then theta is equal to 23 degrees. So again, the directions will tell you where to round, but when in doubt, go to the nearest whole number. That illustrates all the steps that you would need to use for a right triangle. So let's do another example, which is example 3. Same concept, you're doing it the exact same way. For those of you who have already started the problem and want to make sure that you did it correctly, if you did it correctly, you should get 17 degrees. First step is to label your triangle. There's your theta. So across from theta is your opposite. Across from your right angle is your hypotenuse. So 13 would be your adjacent. Opposite and adjacent lines up with the tangent function. So step 1 taken care of, step 2 taken care of. Step 3, set it up. Tan theta equals 4 over 13. And now we prepare to solve it. So theta comes in front. Tangent becomes tangent inverse. And then you let the calculator do its work. And if you put it in the calculator, you get 17.1 degrees, or just 17 degrees. Again, your directions will tell you where you need to round. Let's pause for a second just to give you a moment. And then we'll switch and do a word problem example. All right. So example 3, we're not going to do it together. We're not going to do it together. However, if you were to have done this problem correctly, you should get C as your answer. You should get 56.9 degrees as your answer. Again, that's your theta. So there's your opposite. There's your hypotenuse. 6 would be your adjacent. So again, we're not going to do it together, but that's the answer that you should get if you do it correctly. Same thing with problem 13. We're not going to do it together, but if you solve out the problem correctly, theta should equal to 24.6 degrees or 25 degrees if you're going to the nearest whole number. Again, from theta, that's your opposite, that's your hypotenuse, and the blank side is your adjacent. So sine would have been used here. So now let's do a word problem example. A 1,023-foot wire from the top of a tower makes an angle with the ground and touches the ground 480 feet from the base of the tower. What is the angle made with the ground? So, first step to a word problem is always read it. A 1,023-foot wire from the top of a TV tower. So, here's a TV tower. And you have a wire from the top of the TV tower going to the ground and touching the ground. So there's your wire. It touches the ground 480 feet from the base of the tower. So the base of the tower is the bottom of the tower. So 480 feet. You're looking for the angle made with the ground. So that's where your theta is located. The wire is 1,023 feet. It's 480 feet from the base. So there's your setup. So there's the setup for your word problem. Remember, the hardest part about a word problem is setting it up. But now that it's set up, you can solve it. So let's go about solving it. Across from your theta, your opposite. Across from the right angle is your hypotenuse. Your 480 would be your adjacent. So you know something about the hypotenuse, you know something about the adjacent, so that means cosine is going to get used here. Cosine is going to get used. Now we fill in the formula. Cosine theta is equal to 480 over 1,023. Yeah, you don't have to worry about reducing the fraction because we're getting ready to put it into the calculator. If reducing the fraction makes you feel better, that's fine. But in this case, you don't have to worry about it. Now we get ready to plug it in the calculator and be done with the problem. Move the theta in front equals cosine inverse of 480 over 1023. Now we're prepared to let the calculator do the rest of the work. So that gives you 62.0 degrees, which you can go ahead and make 62 degrees. So this wire is making a 62-degree angle with the ground. The wire is making a 62-degree angle with the ground. And that completes the problem. So last but not least, I'll go ahead and at least throw up the answer for problem 11. That way we've completed all of the right triangle trig examples. So for problem 11, if we were to do the problem correctly, your theta value would equal 63.6 degrees. 64 degrees if you round to the nearest whole number. Now, notice that we didn't use secant, we didn't use cosecant, and we didn't use cotangent for right triangle trig. We don't use those three for right triangle trig if we're finding a missing angle or finding a missing side. That's only for ratios. But that completes this first half of the notes for section 13.4, which is finding missing angles as it relates to a right triangle. On Monday, we'll continue on with the rest of this section by looking at how do we solve and find angles outside of right triangle trig.